Hello everyone. Today I'm going to show you how to assemble the DIY kit for the SATURNUS Nerf Open Chrony. First, we're going to assemble the main control board. For this, we'll need the following components from your kit: the PCB itself, 10 header pins, and a LiPo connector or a 9-volt battery connector. For the purpose of this video, we will be using the LiPo connector. We'll also need the slide switch that comes with the kit, as well as the Arduino Nano microcontroller. I personally also prefer to use a solderless breadboard to hold the header pins in position while I solder them on, but you can use whatever method you prefer. To begin, we first separate the header pin strip that is provided into a 4-pin header and 2 3-pin headers, like so. We now insert the 4-pin header into the solderless breadboard and place the PCB upside down over it. Now we will solder the two together. This connector is for the main OLED screen, which will display the measurements taken by the chronograph. And there's our first connector done. Next, we will do the same thing with the two 3-pin headers, inserting them into the breadboard and placing the PCB upside down over them. These two connectors are for the two IR sensors that detect the dart. Now we move on to the microcontroller itself, orienting it so the USB port hangs over the edge. We only need a handful of the pins on the back, but we will solder all of them to guarantee a secure mount. The second to last component, the switch, only 2 out of the 3 pins are used as indicated by the white dots, but we will solder all 3. And last but not least is the battery connector. There, all done. Let's check the switch to see if it works. We have our completed control board ready to be mounted into the case. Now we move on to the final assembly. You will need the 3D printed case, your assembled PCB that we just finished putting together, the 2 IR detectors for sensing the darts, and the OLED display. You will also need 4 M2 screws, 2 M3 or 440 screws, and the 10 DuPont jumper wires. Let us begin. First, we will need to open the 3D printed case. To do this, turn the case so that the slot is facing you and insert a flathead screwdriver against one edge of the slot. Instead of prying it open with a levering action, twist the screwdriver like so and the lid will pop right off. Now that we have the case open, we can place the assembled PCB into it. The PCB is secured by 4 M2 screws that come with the kit, which we will now insert. Phillips head screws are provided to prevent over-tightening, but caution is still advised as the screws are self-tapping and will strip the plastic if over-torqued. With the PCB installed, we are now ready to plug in the IR sensors and display. Take the 10 jumper wires and separate them into 2 groups of 3 and 1 group of 4. Take a 3-wire strip and plug it into one of the IR detectors. Take note that the pins labeled output, ground, and VCC. These correspond to the pins labeled O, G, and V, respectively, on the PCB itself. We will now plug the other end of the wires into these pins, taking care to ensure that the corresponding pins are matched up. We will now repeat this process again with the other IR detector. After they're both plugged in, we can now place the IR detectors into their alignment slots, pushing on the blue square potentiometers with your finger to insert them until the hole on the board is aligned with the hole in the slot of the case. We will now repeat this process with the other detector. We will also bend the jumper cables in to allow the lid to close more easily later. Be careful not to unplug any of the cables as you bend them. With the detectors seated in place, we will now fasten them with the 2 larger screws provided. If you need any replacements, both 440 and M3 screws between 6mm and 12mm in length will work. Again, take care not to over-tighten these screws. We will now move on to the last component, the display. Take the 4-wire strip of jumper cables and plug them into the back of the display. Take note of the pins labeled ground, VCC, SEL, and SDA. Again, these have corresponding pins on the PCB labeled similarly. We now plug the other end of the wires into the 4-pin header on the PCB, taking care to match the corresponding pins. Once plugged in, we can remove the protective coating on the screen. I find that it's best to roll up the excess wire by flipping the screen by a full 360 degrees. Now with care, slowly slide it into the slot on the front side of the case that holds the display. Congratulations! Now you have finished assembling the chronograph, and we can move on to the last part and final step. Now that the Chrony is fully assembled, we can plug in the battery, taking care to ensure the correct polarity and tune the sensors. First, turn on the chronograph, and you should see the power LEDs on both sensors turn on. Next, turn the blue square potentiometer all the way clockwise until the sensor LED turns on. Now turn the potentiometer counterclockwise until just after the LED turns off. This sets the detector to the highest sensitivity without providing a false positive reading for your lighting condition. Repeat this process on the other sensor. In this case, I have already done this for the other sensor, so we will move on to the next step. To obtain an accurate reading, we need to ensure both detectors have the same sensitivity, which means they will detect an object from the same distance away. With both sensors currently at their respective maximum detection ranges, which may not be equivalent to each other, we want to reduce the range of the more sensitive sensor to be the same as the other. To do this, place an object large enough to span both detectors in front of the sensors, and starting from a few inches away, move closer until both sensor LEDs turn on. Take note of which LED turns on first and reduce the sensitivity of that detector by turning the potentiometer for it counterclockwise until both sensors detect the object at the same maximum distance. Now the chronograph is ready to measure some dart velocities. Happy nerfing and thanks for watching.